lot of serous with a little bit of mucus. That always equals submandibular. You'll also note with mucus clustering, you can have caps of serous, little crescents. Here, here, here. But this is the best one. Demi-lune. Demi-lune means crescent. So we say, yeah, even you'll hear serous demi-lune, which is redundant. Demi-lune automatically is serous. Okay? You don't see demi-lunes in carotid because there's no mucus. It's only when you have them capping the mucus cells. Also, you need to know the duct sequence for salivary glands. So I'll ask, what is the smallest duct found in salivary glands? Don't point to anything, it's strictly descriptive. Intercalated, which go into larger ducts, striated, and then into excretory ducts. So that's the list on your handout where you can know the 3 levels of ducts. You can actually see this is an intercalated right there. Is going into a striated, which is right here. Larger, thicker wall. If that's no ID, it's strictly asking you, do you know those 3 levels? All right. And then you take a look at the next one. Oh, that looks like all light cells. Mucus. So we now say, oh, it's almost all mucus. Gotta be?
Sublingual.
Sublingual. Great masses of mucus cells. Though you still have serous, disload little dark areas, little serous clusters. So we say mostly mucus, but you can still have serous, little demi-lunes. Would greatly magnify those for any identification. So now you have your progression for next week. All serous is parotid, almost all serous with a little bit of mucus is submandibular, and then almost all mucus with a tiny bit of serous is sublingual. So if you have that in your mind, you'll have no problem identifying salivary gland tissue. All right. Now we can go to the esophagus, where you first identify the 4 consistent layers of the GI tract wall. So it's just a matter of starting at the lumen, very thick from here all the way to where it lightens up. That's mucosa, ear to ear. The second layer, much lighter, usually lots of holes in it, which are blood vessels. Highly vascular layer, submucosa. Then it gets very dense and dark. The third layer, we often call the peristaltic layer, the muscularis externa. Be aware that there are 2 grains to this layer. Inner circular, runs around the lumen. As you move out, it shifts 90 degrees to go longitudinal, which is this layer. Hopefully in lecture you might remember the nerves that control it, which are sandwiched in between, not for identification. Eponymic name, our box. That's for lecture. And we say it's so important, should really get a little repetition from lab. And say, yeah, right in between circular and longitudinal, there's a massive nerve plexus. Controls peristalsis. And then your fourth layer, the Saran wrap, histologically named serosa, corresponding to visceral peritoneum. I will allow you to use those interchangeably. You know this is serosa, you can also call it visceral peritoneum. But you have to make sure you're indicating visceral, what's on the viscera, not on the wall. So those are your four consistent layers. I'll only ask you them in the esophagus. The other compartments, you have other things to focus on. The last step is to get really magnified on that first layer of the mucosa, sort of a darker blue to reddish layer. So magnify this another 100 times, and you see this. Stratified squamous, the stacks of cells. Once you see that, you can identify this as esophagus. Nothing else going on other than stacked cells, helping to protect the interior of your esophagus. All right? When you get this darker bluish to reddish zone on the first layer, gotta be esophagus. Maybe in lecture, you know, connective tissue, a little muscularis mucosae muscles there, little bundles, esophageal glands, which is just sublingual gland tissue. My lecture, we talk about Meissner's coming up from the submucosa to activate these little bundles. But they really don't do much other than rippling the mucosa. No connection to peristalsis. That's over here, external. All right. And then we move along from esophagus. There's your stratified squamous. Attaches to the stomach, completely changes, radical change. Simple columnar. You don't see very well at this magnification. The main thing are the pits. It gets this pitted appearance on its surface. Always an instant indicator of stomach when you see the pits. Okay. So this is the gastroesophageal junction. Or my lecture students abbreviated as the LGJ. The controversy, LGS. You'll hear of this as a sphincter. It's not. There is no muscular ring here. It's a physiological sphincter, not an anatomical one. Which just means our box is more active to keep this more clenched, thereby trying to minimize reflux up into your esophagus from your stomach. My class, LGJ, you'll hear it all the time as the LGS. Well, the only problem, or many physicians think there's a muscular ring there, when you know better. There is no muscular ring. You can actually see there isn't one. And still, it works like a sphincter neurologically. And then you look at fundic stomach. So, well, there are your pits. So this pinhole effect. And then into the mucosa, millions of gastric glands. Upwards of 3 liters a day coming up into the lumen of your stomach. In all these millions of gastric glands with billions of cells. So all we do for the physio of the stomach is isolated on the cells of the gastric glands. Initially at low magnification, this is only 50x, you see a reddish zone higher up, parietal cells. And then as you descend, more dark cells or blue to purple, chief cells. So you want to magnify, kick it up another 100 times, and now you get a nice clear look at the pits. You can see the simple columnar epithelium, looks like a skyline. The nuclei are at the base of the cells. And then clustered in the pit are mucus cells. Here, thousands and thousands of mucus cells. Part of your GMB, helping to protect the wall of your stomach. And then as you descend into the gland, you see the parietals, dominant, big, angry-looking cells here. And then we have to go deeper down, where we pick up on the blue cells, clustered together, chief cells, the most numerous. But even deeper down, you can see chief cells. Here's a parietal. And then every so often, you'll even see mucus cells. Not staining at all. Just like they were higher up. Mucus cell, mucus cell, mucus cell. So even deeper down, you can find all 3 cell types. It's easy to make. Chief, parietal, mucus. The 3 cells of the gastric glands. That's everything you need for gastric histology. The cells of the gastric glands. All right. Now pass out of the stomach into the small intestine. This always tells you it's small intestine. The fingers, billions of them sticking up into the lumen. You know them as?
Villi.
Villi. So villi always equals 1 or more parts of the small intestine. It runs throughout. You then go to the base of the fingers where there are these little pockets. See it better over here, more magnified. These are the intestinal glands or crypts, little caves. And then if you go deeper into the submucosa, right here, you have these glandular pockets, mucus cell clusters. Brunner's glands. Whenever you see Brunner's glands, always equals
Duodenum.
duodenum, the first part of the small intestine. So villi always equals small intestine. Brunner's glands always equals duodenum. Okay? And then if you're really good and your eyes are sharp this morning, you can start to see these little bubbles. Just a little bit in the duodenum. Very important cell or tissue, goblet cells.